This is question 8 from paper 1 from the 2020 Leaving Cert higher level maths paper. Up the top right of the screen you'll find a card that will bring you to the playlist where it has all my solutions to the questions in this paper. And below the video you'll find a link to an image of this question so you can try it in your own time. Now this question is the second long question in this paper. It revolves around this shape here, a rectangle inside a circle. It tells us a few different things. It tells us this length here 5, really that's it I think. It tells us this angle is between 0 and pi over 2, which is 90 degrees. That sort of makes sense. If you're modelling a rectangle, it would go from here to here. Draw out a few of them. One angle would be, actually I don't want to ruin this drawing, but one angle, a low angle, would give you a rectangle like this. A higher angle would give you a rectangle like this. There's no point going past the 90 or below the 0. You can get any shape, rectangle that would fit in there. Part 1, or part 1 of this question, then tells us that the point or xy can be written as a cosine theta, b sine theta. Find the value of a and b. So what they're saying there is, instead of writing x, what could we write? That's the first question to figure out. Now if you can't do it, they've given you the answer so you can move on to the next part. But how we do this is we look at this triangle they've set up in here. There's a theta, there's a 5, there's a right angle. We know a lot of it. Well, we know two things exactly, and theta, we're happy to have theta in the answer, so this is pretty good. We could write in x here and y here. That's what x tells us. It's x away from the 0 point. It's x distance on the horizontal away from the 0 point, meaning this length here is x. And the same with y. It's y up. Here, this is y. This is y. Therefore, this is y. So we know a lot about this. They would like. Let me write out what they want. They want a cosine theta. Let's just deal with that one for a minute. Well, we look at cosine and we think about a right angle triangle. What do we know? We know that cosine of theta is equal to the adjacent, which is x, divided by the hypotenuse, which is 5. If I rearrange this, I get x is equal to 5 cosine theta. And that's what they wanted. They wanted, instead of x, they wanted a number multiplied by cosine theta. We get that. Similarly, if we think about sine theta, that will be equal to y divided by 5, or if you rearrange that, you'll get y is equal to 5 sine theta. So that's the answer. A and B are 5 and 5 in this question. The second part of this is show that a theta, the area of the rectangle, is equal to, and they give us the number. Whenever they ask me to show something like that, I try and ignore the answer they've given me. So they told me what a theta is equal to, or what the area is equal to. Try and forget that and try and find it yourself, because that's really how we show that it's equal to that. First of all, some people are confused by this. That just means the area, like a function in theta though, that is the area. So the area is equal to, and it will have some things with a theta in it. Maybe multiple thetas, maybe theta squared. Now we know what it is because they told us already. That's all that is. It's a function in theta. So theta will be in this function. So what's the area of this shape here? There's a few ways you can do it. How I would think about it is I'd look at the rectangle up here. Just one of these mini rect. Let me shade that in. This rectangle here. So we know this is x and this is y. Or we know x is this and y is this. The area of this rectangle is equal, let me write it here, because I just want 4 of these rectangles. These are all the same area. Those multiple different shapes I did, they'd be equal either way. They're all symmetrical. So that'd be equal to 4 multiplied by x, which is 5 cosine theta, multiplied by y, which is 5 sine theta. If I multiply all this out, 4 by 5 is 100, and then we get cosine theta sine theta. Oh, okay, so that's not what they wanted yet, but it's quite easy to get from here to the answer. If we split this up into 50 and then 2 cosine sine theta. Now you do this because if you looked in your formula tables at some formulas, you'd notice that this is equal to this in your formula book. Sorry, this is equal to, well, let me just write it out. Sorry, this is equal to sine 2 theta. And this is what we were looking for. We could use the clue they gave us. That's another reason. That's when I start looking at the answer they've given me, when I might need it. This is equal to this. And you can just go ahead and use that. If it's in your formulas, you can use it. Where this comes from, I won't prove it, but I'll just show you it quickly. It comes from the formula, I can't remember what this is called. The formula when you're adding up angles, I guess. There's a few of them, sine, cosine, all of those, but sine 2 theta is just like theta plus theta. If you put that into the formula, you'd just get this. Or you would get 2 times this. Yeah, sorry, 2. Yeah, you'd get exactly what's there. Okay, sorry, I rambled on a bit there. That's the answer, that's full marks. Let's move on to the next bit. I'll rub out here. I'll just need a little bit of room and we'll do part 3. Okay, part 3 asks us to use calculus to show that the rectangle with maximum area is a square. Now they've done us a bit of a favour there by saying use calculus. They didn't have to. They could have just said show that it's a max, or show the maximum is a square. So when we see maximum, we should be thinking that the maximum area. So when we think maximum, we should think differentiation. Well, let me not write it this way for a moment. A theta. We should think the derivative of this. Or you could write that as dA d theta. That'd be fine as well. You could also leave this in here if you wanted, but we wouldn't usually leave that in. It's the fact that the theta is here is sort of showing that this is a function with theta in it. So yeah, we use the fact that this is equal to 0. At a maximum, this is the same thing. Is equal to 0. So let's just go ahead and differentiate. And differentiate this guy here. Here's the area. The derivative of this is equal to 50. We don't care about 50. The derivative of sine of something is cosine of that thing, 2 theta. But this is a complicated thing inside the sine function. Sorry, here. This is complicated inside the sine function. So we better use the chain rule when we differentiate this. So the chain rule says you'll just have to differentiate this later. So the derivative of 2 theta is just 2. So multiply this by 2. Let's squeeze it in the front here. So this is equal to 100 cosine 2 theta. Let's see. Use calculus to show that the maximum is a square. We also know this is equal to 0. Therefore, we know that cosine 2 theta is equal to 0. Now let's think about the cosine function. I'll draw it in here. Cosine function looks like this. But theta only goes between 0 and 90 degrees, they told us. So 2 times theta would only go between 0 and 180. So here's 180. Sorry, this should have continued on like this. 180 is here, so I'll go ahead and rub this bit out. This is the cosine function of here. When is this equal to 0? That's quite straightforward. When it's equal to 90 degrees. When this in here is equal to 90, I'm sorry, we're using radians. So this happens when 2 theta is equal to pi over 2, or 90 degrees. And that means that theta is equal to pi over 4. Think of that, that's 45 degrees. So let's see, so show that that's a square, I guess. I guess you don't really need to. It would be enough to say therefore a square. That would be fine. I guess you could just talk for a few moments about how a square with a 45 degree angle here, or a shape here with 45 degree angles here, has to be a square. And if this is 45, this is 90, this up here is 45. Let me try that again. If this is 45, this is 90, this has to be 45. This is 45, this is 45. These are equilateral, these are isosceles triangles then. And this is equal to this. Also by symmetry, this is equal to this. Therefore, these two are equal to each other. They're all equal to each other. All these little mini squares or these little shapes are equal to each other. Has to be a square. But honestly, the exam would be happy enough just using your common knowledge, common sense that 45 degree in this sort of thing has to be a square. All right, let's see. Oh, find the maximum area. We can go ahead and do that now. I'll leave A equals this here. To do that, we know the angle is pi over 4. We know the area is equal to this. So the area of pi over, the area when the angle is pi over 4 is equal to 50 multiplied by sine of 2 times the angle, which is pi over 2. And sine of pi over 2 is equal to 1. You can go ahead and draw a sine function like this. When 90 degrees is right here, which is equal to 1. Or put it on a calculator, that's fine. So therefore that's all equal to 50. So the area of this shape is 50, and that's the answer to A. And let me clear all this off, and we'll do part B. It's not a very difficult question, but it's completely unrelated to this, which is sort of nice. That breaks up these long questions sometimes. Okay, part B of this question gives us this drawing here, and it tells us a story about a person who's 2 meters tall. Think of this line here as that person. A street light that is 5 meters tall. Think of this line here as that object, and the light is shining off it and casting a shadow. So this is the person's shadow along here, and that is X meters long. This person's walking along at a speed of 1.5 meters per second, and they'd like us to find out the speed the shadow is changing. Now there's two things that jump out at me when I look at this question. One of them is that what they're asking us. They're talking about the speed, the change. Now that there should be a clue in what question we're in. What did we do the previous part? We did some calculus. So we should be thinking of speed in terms of the change of velocity, the change of position, I mean. So the speed of the shadow moving is how much it moves, it changes over time. That's what we should be thinking. And how the person moving. The person is moving towards the street light. So it's really just dl dt is equal to 1.5. So we should be thinking of those. They should be jumping out at the start of the question. We'll come back to them in a minute. Another thing that jumps out at me here is that we actually have two triangles. We have this, let's make that the small one, and we have this big one. They're equal. All the angles are equal. These two angles are equal, and these right angles are the same. We also know that this one is 5 tall and this is 2 tall. Let's see, the small one here, we can write x there. The large one is x plus L. They're similar triangles. That comes up a lot in maths. You should be keeping an eye out for shapes like this in maths. In maths exams at least. They come up all the time where they cut a triangle apart with two parallel lines here. This line is vertical, this is vertical, they're parallel. So that allows us to do ratios. The ratio of these two sides is the same as the ratio of these two sides, which tells us 2 divided by 5. Do I want to do it the other way or anything? Let's do it, keep it this way. 2 divided by 5 is equal to x divided by x plus L. So there are the two things that jump out at me. The fact that I'm dealing with derivatives, because speed is a derivative of distance, and the fact that I have similar triangles. And that's enough to answer this question. We can put this together a couple of different ways. First thing, I play around with this to get x equals L or L equals x, something like that. So let's do that now. Let's see, multiply this side, we get 2x plus 2l. That's this bottom multiplied by that top is equal to this bottom multiplied by that top, 5x. Let's get everyone the same side. All the x's are 3x equals 2l. And we'll get L equals, because I can see that's what I want in a minute. But if you got X equals, that's fine. You can figure it out in a moment or two. Let's write them both down. L is equal 3 over 2x, or X is equal 2 over 3L. Just move these around. Or from this line here, solve a different way. 2 divided by 3. 2 divided by 3 here. X is equal 2 divided by 3L. Either of these. That's just from the similar triangle now. That's just from the similar triangle you should get to this point, even if you don't think of the calculus involved. Now we're pretty much done here. Like I said, there's a couple of ways. You could have used the chain rule to get these together, but I think it's easier just to use this guy here. If we notice, that's his speed. As he moves, L changes. L is, he's moving along L here. So the derivative of it is equal to his speed. Instead of L, let's just put in L, or 3 over 2x. Because 3 over 2x is L. If we just put that, dt, well, the derivative doesn't care about a constant multiplying by something. So we can take the 3 over 2 outside. So we get dx dt, I keep writing x on the bottom row, dx dt, and remember all of this is still equal to 1.5. This was just dl dt, and we changed it into dx dt. But we want dx dt because that is what they asked us. They asked us how fast the shadow is moving. It's going over distance x here, so the speed must be dx dt. Well, dx dt is equal to 1.5 multiplied by 2 divided by 3. 1.5 by 2 is 3. 3 divided by 3 is 1. 1 meters per second. I would say I'd be a little careful about the signs. Is the shadow getting bigger or smaller? The person is going plus speed, they told us that. So is the shadow going at plus speed, getting bigger, or going at minus speed and getting smaller? Because I was a little hand wavy saying that dl dt is equal to 1.5, maybe minus dl dt is equal to it. It doesn't matter in this question, but you could. I would suggest being a little careful about that. We can test that out by just moving the person here, moving them down. Let's see what happens to them. We would get a smaller shadow. The person would be going a plus speed, and the shadow is getting smaller. Oh, but L is also getting smaller. So L is getting smaller, X is getting smaller. So I could say that the person is not going 1.5 meters per second. I could say they're going minus 1.5. And therefore, the shadow is going minus 1. But I guess since they gave us this as a plus, they gave us this direction as a plus, which is a little unusual, we might as well give them this answer as a plus as well. Because X is also getting smaller. Which is this direction is usually smaller, this direction is bigger. Anyway, that's more for a mechanics paper or for a physics paper. For now, this is perfectly fine here, 1 meters per second. If you have any follow-up questions about either of those two, feel free to ask in the comments. Me or I'm sure somebody else will happily answer them. But try the question over and over, pause, replay things. This should take you a while. These long questions should take a lot of study to get through. They ask so many different things. Alright, thanks for watching and have a great day.